Hello all, welcome to Gurukul CAT 100 series, a series designed to take you from your study room to your corporate boardroom. I am Deepak and this is Daily Quant with Deepak. Hi all, welcome back to day 42 of 100 days to CAT Quant series. In this video, we will be discussing 5 questions from algebra. So whenever a question is displayed on the screen, pause the video, try solving that question. Once you're done solving, you can resume the video. If you find this video useful, like the video, share this video with your friends who are preparing for CAT, and most importantly, for more videos of this kind, subscribe to this channel. In case if you want to attempt these 5 questions as a test, you can log into our portal, the gurukul.org.in, where you'll find a course called 100 days race to CAT, in which there will be 3 sections: quant, LRD and VRC. We will be uploading 100 tests in each section. So if you are a serious CAT 25 aspirant, you cannot afford missing these tests. So without any further delay, let's get started with the first question. Now coming to the first question, the number of integers and that satisfy the inequalities mod n minus 60 less than mod n minus 100 less than mod n minus 20 is. Now to solve this question in the easiest possible way, I want you to understand that on a number line, now let this be 3 and let this be 7, plus 3 and plus 7. Now what is the difference between these two? 4 units. How did we get this? 7 minus 3, right? Now let me take number 12 here. What is the distance between these two? 12 minus 7, 5 units. So if you have 2 points on a number line, the distance between them is nothing but the difference between those 2 points. Clear? Now we'll be applying the same logic to solve this. Right. First, let me take this inequality. Modulus of n minus 60 less than modulus of n minus 100. Right? So we have a number line here from minus infinite to plus infinite. We have 0 here. Let this be 60. Let this be 100. Right? Now, let me take a point on the negative number line. Let me take a point here. Now, what would be the distance between these two? Let this be x. Right? Distance between the point and 100. Let this be y. Now, I can say that y is greater than x and we need that. Right? Okay. Now this is when the point is to the left of 60. Now if the point is to the right of 100, now if I take a point here and if this distance is a, if this distance is b, right? Now we have a greater than b. So n minus 60 is greater than n minus 100. So we cannot consider the values to the right hand side of 100 or more than 100, right? Now between 60 and 100. Now let's see. If I take the midpoint of these two, which is 80. Now 80 minus 60 is equal to 100 minus 80, 20 units and 20 units. Now if I make this 81, okay, now this distance is 19, this distance is 21, right? So for the value of n greater than 80, this inequality is not being satisfied, right? And n minus 60 should be strictly less than n minus 100, so that cannot be 80 as well. So the range of values that n can take considering this inequality will be from minus infinite to 80, not including 80, excluding 80. You cannot consider 80 because you do not have less than or equal to. It's strictly less than, right? Done. So these are the values, range of values that satisfy this inequality, right? Now coming to the second inequality, where you have n minus 100 less than modulus of n minus 20. Now we'll apply the same logic. Now we have 20 somewhere here, right? Now n minus 100 to be strictly less than n minus 20. Now let me take a point on negative number line, right? Now if this is a, if this is b, we have b greater than a, but we should be having a greater than b. So this inequality is not satisfied for the values less than 20. Okay. Now let me consider a value greater than 100. Let me take the value here. Okay, this point. Now if this is b, this would be a. So we have a greater than b. So the distance between these 2 points is greater than the distance between these two, right? So this is satisfied, this inequality is satisfied for all the values greater than 100, right? Now between 20 and 100, what is the midpoint? 60, right? Now when n is equal to 60, or the distance between these two is 40, and the distance between these two is also 40, right? Now if I take the value to be 61, right? So you have this distance as 41 and this distance as 39. Now since modulus of n minus 100 to be strictly less than modulus of n minus 20, then the value cannot be 60, right? So for all the values, integer values from 61, you have this inequality being satisfied, right? So the range of values would be 60 to positive infinite excluding 60. Now we need to find the range of values which satisfy both the inequalities, right? So we have 60 to 80 excluding 80, and we have 60 to plus infinite, right? This is minus infinite to 80, and this is 60 to plus infinite. So the region common to both the inequalities is this, and excluding 60 and 80. So we should be considering the integers from 61 to 79 including both. So how many integers are there from 61 to 79? 79 minus 61. Now since we are including both, plus 1. So the answer for this question should be 19. Hence option D should be the answer to this question. Now coming to the second question. For how many integers n will the inequality n minus 5 into n minus 10 minus 3 into n minus 2 less than or equal to 0 be satisfied? Now let me expand this. So you'll be having n square minus 15n plus 50 minus 3n plus 6 less than or equal to 0. Right. So this is nothing but n square minus 18n plus 56 less than or equal to 0. So 56. Now we need to write 56 as a product of two numbers, which one add up to give us minus 18. So they are minus 14 and minus 4. So I can write this as n square minus 4n minus 14n plus 56 less than or equal to 0. Now this is n minus 4 into n minus 14 less than or equal to 0, right? So 0, 4, 14 plus minus plus, right? So this inequality is satisfied for all the integers between 4 and 14 including both, because you have less than or equal to 0. So how many numbers do we have from 4 to 14 including both? We have 11 integers. So the answer for this question should be 11. Now coming to the third question, how many pairs of integers a comma b are possible such that a square minus b square is equal to 288? So we are asked to find the number of ordered pairs a comma b such that a square minus b square is equal to 288. Now I'll write a square minus b square as a minus b into a plus b. Now this should be 288. Now let's factorize 288. Let's write 288 as a product of two factors, right? So I can write that as 1 into 288, then 2 into 144, then 3 into 96, 4 into 72, 5 is not a factor of 288, 6 into 48, 7 is not a factor of 288, 8, 8 into 36, then 9 into 32, then 10 no, 11 no, and 12. 12 into 24, then 16, 16 into 18, right? And then 18 into 16, 24 into 12, and so on, right? Now if you observe, if I take 1 and 288, a and b, they have to be integers, right? Now can the sum of two numbers be even and difference be odd? No. If the sum of two numbers is even, the difference should also be even, right? When the both the numbers are even or odd, right? So this is not possible. And we do not get integer values for a and b. You will be getting in decimal values because one is even and one is odd. Now here both are even, possible. Now one is even and one is odd. This is not possible. Both are possible, yes, yes, and this is not possible. So we have how many values? 1, 2, 3, 4, 5, and 6. Now 6 values, right? Now reverse are also possible. You can also have 18, 6, 24, 12, 36, 8, 48, 6, and so on. So you'll be having 6 more values. So in total 12, right? Now when we write down the positive factors of 288, right? Now again, a minus b into a plus b is equal to 288. Then we can also write that as minus 1 into minus 288 because a and b can be negative. Right, minus 1 into minus 288, minus 2 into minus 144, so on till minus 16 into minus 18, again minus 18 into minus 16, minus 24 into minus 12, minus 36 into minus 8, and you will be having 12 more values of A and B. So in total, there are 24 ordered pairs of the form A and B where A and B are integers. So the answer for this question should be 24. Now coming to the fourth question. 3x plus 4 mod y is equal to 33. How many integer values of x by are possible? So there are two cases here. So 3x plus 4y is equal to 33 or 3x minus 4y is equal to 33. We need to find number of integral values for x and y, right? So when y is 0, x is equal to 11. Now let us reduce this by 4, right? And this will get increased by 3. So when this is 3, this would be 7. And let us increase this by 3, 6, 3. And then again increase this by 3, 9, then minus 1, and so on. So you will be having infinite values for x and y. And in this case also, if y is 0, this is 11. Now let me increase this by what? 4, 15, and let us increase this by 3, right? So whenever you have an equation of the kind ax plus by is equal to 0, and to find the integral solutions for this equation, right? So always you need to find the first value, right? So here you have 11, 0. Now the next value will be 0 plus a, the coefficient of x, and the corresponding value of x will be 11 minus b, the coefficient of y. If you have an equation in the form of ax plus by is equal to 0. Now if you have an equation in the form of ax minus by is equal to 0, here the first value 11, 0, right? So these are the one of the values of x and y which satisfy that equation, right? To find more values, all you need to do is you need to increase this by a and increase this by b, where a and b are coefficients of x and y, right? So you will be having infinite values here. So the answer for this question should be option D. Now coming to the final question. Find x if log x cube minus log 3x is equal to 2 log 2 plus log 3. So we have log x cube minus log 3x is equal to 2 log 2 plus log 3. Right. So log x cube minus log xy can be written as log x plus log y. So I'll be writing log 3x as log 3 plus log x is equal to 2 log 2 plus log 3. Then we have log x cube minus log 3 minus log x is equal to 2 log 2 plus log 3. Now sending minus log 3 to right hand side. So we have log x cube minus log x is equal to 2 log 2 plus 2 log 3. Now let me take 2 common. So 2 into, you will be having log 2 plus log 3, log x plus log y can be written as log xy, log 2 into 3, log 6, right? So you have 2 log 6. So here log x minus log y can be written as log x by y, so log x cube by x. Now this is equal to log 6, right? So x cube by x is equal to x square. So we have log x square is equal to log 6 square. Now this is possible only when x square is equal to 6 square or x is equal to plus or minus 6. But can we have the value of x being minus 6? No. Right. So the answer for this question should be 6. Option B should be the answer to this question.
Hope you enjoyed learning from today's session.
This series is designed to help you with your CAT preparation and practice daily. We are with you in this journey.
To watch the next video, click here. And to watch Gurukul's CAT 100 series, study room to boardroom, the entire playlist, click here.
If you learned from today's session, like, share, and subscribe.